All right, last video, hopefully. We're on question 34, and so we'll take this right to the end. So let's keep it going. Question 34 says we're going to simplify the following function. All right, I've got the square root of 2 times the square root of 10 plus 8. So our first step per PEMDAS is we're going to go ahead and distribute. And square root of 2 times square root of 10, well, that is 2 times 10. That is the square root of 20. And then my next step, square root of 2 times 8. So that is 8 times the square root of 2. And the last step I need to do, because it told me to simplify, I want to simplify down any radicals that I've got. And in this case, the square root of 20 is something we can simplify. So the square root of 20, I hope you agree with me, can be written as the square root of 4 times 5, since 4 times 5 is 20. And the square root of 4 is something that we know. The square root of 4 is 2. So let's go ahead and rewrite. So we can rewrite the square root of 20 as 2 root 5. And then I've got plus 8 root 2. Well, at root 2, there's nothing more we can do with that radical. So we'll just leave it alone. All right, that's how we do 34. Let's keep it moving. All right. Question 35 says, find the x-intercepts of the function graphed below. Okay, so our x-intercepts, well, our x-axis is here. This is our x-axis. And so we're going to go look for the 2 points where it crosses. It crosses right here at -2, and it crosses right here, and that's between 2 and 4. So let's say that that's 3. So -2 and 3 are the two answers that I am looking for here, -2 and +3. Moving over here, where are the y-intercepts? So this is our y-axis, and we cross right here, and that is at the point -6. So that's the answer I'm looking for there. All right, let's take it up a notch. 37. A savings account balance is compounded annually. If the interest rate is 4%, that means it's growing. You give the bank money so it grows. Is 4% per year, and the current balance is $1,859. What will the balance be 5 years from now? So let's start with our formula. Here's what our formula says. It says A1, our starting amount, times 1 plus R, where R is our rate as a decimal, raised to the power of time, or t. So let's go ahead and do it. So A1, that's our initial value. Here, that's 1859. The next part is 1 plus R, our rate. In this case, our rate here is 4%. Don't forget that when we use rates in formulas, we need to convert it to a decimal. So if you divide 4% by 100, you get 0.04. So that's what we're going to use for our R value. And then we're going to raise it to t, or time. And in this case, we want to know the balance after 5 years. So to the exponent of 5. I want you to take this and plug this into your calculator. After you've plugged it into your calculator, hopefully you get an answer. Of this, $2,261.76. That's what the answer should be. All right, question 38. Let's keep it moving. We're almost there. For a period of time, an island's population grows exponentially. If the continuous growth rate is 2% per year, and the current population is 1,572, what will the population be 7 years from now? So the difference between these two questions, this was an interest question. Savings account was compounded annually. Over here, we have continuous growth. Whenever you see the words continuous growth, we need to use our PERT formula. So that says P for principal or initial amount times E. E is a given. We know what the value of E is. E is 2.78. Raised to the rate times time. So let's plug in all of our information. So P again is our initial value. Here in this case, that's 15,000 or 1,572. So 1,572 times E raised to the R, where R is a rate as a decimal. In this case, 0.02. Multiplied by time, which in our case is 6. So you take all of this mess, again, you've got an E button in your calculator. I'll even show you where it is. You've got an E button in your calculator. It's just above the division sign, just above the division sign. So if you hit second and then division, you'll be able to get that E button. So type this into your calculator, and hopefully what you get is $1,772.43. All right, hope you got that. All right, let's keep it going. Question 39. So I've got a function, and it says, at what point does an absolute minimum occur? So absolute minimum means the lowest possible point. And in the case of this question, we have an absolute maximum up here, but we don't have an absolute minimum. So the answer to this question is simply none. There is no absolute minimum here. There's no absolute minimum. Notice this parabola goes up. It's got a highest point, but it doesn't have a lowest point. These arrows down here indicate that our function continues down towards infinity forever. So we'll never reach that minimum, that lowest point. It doesn't exist on this graph. It continues down forever. So just watch out for that language there. Moving on, what type of extrema occurs at x equals 0? So when we ask you this question, we're saying, hey, does a relative max or min occur there? Is there an absolute max or min? So we're asking you about the max or mins. That's what this question's asking you. So at x equals 0, this is a relative max. Let's break down those two words. Relative because although this is the highest point in this area, notice our graph kind of crests and then comes back down. It's not the absolute maximum. It's just relative to the function right immediately around it. So these pieces of our graph are higher. So this is a relative maximum point. It's a turning point. It's where we go from increasing to decreasing. All right, y'all, almost there. All right, question 41. An employee receives a 4% raise once a year. If the employee's initial salary is $92,200, what will be the employee's salary after 6 years? Okay, so it's a formula we've used before. So our formula is A1 times 1 plus R raised to the T, where A1, that's our initial value. In this case, it's 92,200. Our R is our rate, 4% as a decimal, that's 0.04. And then our time in this case is after 6 years. So you take that, you plug that into your calculator. What do you get? Let's see, what do you get? You get 116,000. All right, so final answer, 116,662.41 cents. It's 41. All right, 42, solve for k. Okay, for this one here, we need to start with our PEMDAS, our order of operations, and so we'll deal with the parentheses first. I'm going to distribute. So I'm going to distribute my 3 to the 6 and the 4k, in other words, multiply. And then I'll distribute this negative 8 to both of these two terms, 8 and negative 5k. And I'll go ahead and write what the next line of math should look like. Okay, cool. That's what our next line of math should look like. 214 equals 18 plus 12k minus 64 plus 40k. Now we need to combine like terms, and we only combine like terms on the same side of the equal sign. So 18 and negative 64 can be combined, and 12k and 40k can be combined. So I'll now write what the next line of math will be after we combine 18 and negative 64 and 12k and 40k. Okay, so I'm left with 214 equals negative 46 plus 52k. 2 more steps and we're done. The opposite of negative 46 is positive 46. So I'm left with 260 equals 52k. And our last step, the opposite of multiplying k by 52 is dividing by 52. All right, cool. Let's keep going. There's a lot. K equals 5. All right, so 43 is more of something you need to explain. It says, given the mapping below, determine whether the relation is a function. Explain why or why not. So in this case, the key thing to look at here is that our 2 different inputs gave us the same output. So 2 different x values gave us the same y value. That's okay. This is still going to be a function. There's nothing wrong with that. The only thing you want to worry about is it wouldn't be a function because you can't, only time it wouldn't be a function is if you had a single input trying to give multiple outputs. So that wouldn't work. But in this case where we've got 2 inputs into 1 output, we are all good there. Yes, it is a function, so we're all good there. Let's move on to question 44. Find the domain and range for the function below. So I've got a parabola, x squared, and it's been shifted left 7, and it's been shifted down 4. So left 7, down 4. I'll draw y'all what that looks like. All right, cool. So this is what our graph would look like. Y'all could graph this in your graphing calculators, okay? But this is what it would look like. It's got a vertex there at negative 7, negative 4, left 7, down 4. And we're asked for the domain and range of this function. All right, let's go and find out what that would be. So our domain is going to be all real numbers because our parabola extends infinitely far to the left and to the right. So our domain, negative infinity to positive infinity. And our range from bottom to top, well, our lowest y value is negative 4. And our highest y value is infinity. And so for your exam, remember y'all, you're going to have a graphing calculator. So you can graph and figure out what this function looks like. I just wanted to show y'all roughly what it would be. So that's 44. Domain, negative infinity to positive infinity. Range, -4 to infinity. All right, almost done, y'all. 3 questions left. Cab driver charges $12 for a ride plus an additional $6 for every mile. Write a function representing the total cost of your trip as a function of miles driven. So let's say that M equals miles in this world. Let's write an equation for that. So cab driver charges $12 as a base plus an additional $6 for every mile. So 6 for every mile, so 6M. So a perfectly correct answer would say f of m, the function of miles, is 12 plus 6m. So $12 our base charge, and then we're charging $6 for every mile that gets driven. For 46, it says it costs $5 for ice cream, 25 cents for every topping. Toppings are cheap. You spent $7.50. How many toppings did you get? Okay, well, let's go $7.50 minus the total cost minus the ice cream. That gets us $2.50. So I know that we spent $2.50 on toppings. That's a lot on toppings. $2.50 on toppings. So $2.50 on toppings. I know the toppings cost 25 cents a piece. And so I'm going to do $2.50 divided by the cost for one topping, 25 cents, and I will get 10. So 10 toppings were ordered here. All right, last question, question 47. Who's excited? So question 47. Table below shows the distance towards certain tornadoes have traveled related to the wind speed near the center of the tunnel. Use a logarithmic model, ln regression, to estimate the wind speed of the tornado that's traveled 3 miles. So I'm going to kind of write out the steps for what y'all need. Y'all definitely need a graphing calculator to do this, but I'll write out kind of what you need to do. So okay, cool. So what I want y'all to do is for your step 1, I want you to hit the stat button on your calculator, then hit enter on edit, and then I want y'all to type input this data here into L1 and L2. So this first row right here, distance will be your L1 column of data, and then your wind speed will be your L2 column. All right, so pause the video right now. Go ahead and input your data into L1 and L2. Hit stat, then edit, put that data in. I'm assuming now you've put the data in. Now let's go to our step 2. It says I want a logarithmic model. All right, our step 2, I want y'all to hit the stat button, then go over to the calc menu, then scroll down to option number 9. It's called LN regression. So LN for natural logarithm asked us for a logarithmic model. Once you've done, hit enter on that. Hopefully you've got some information. And I'm going to write down the information that you should have gotten at this point. All right, go ahead and check yourself. Is this what showed up on your screen? Y equals a plus b times ln of x, where a is 64 and b is 41. If you did it right. Great job. We're going to go ahead and take our a and b values and substitute them into our equation and write an equation for this function here. All right, cool. So that is our logarithmic regression equation. We're almost done. It says, use this model that we've just created to estimate the wind speed of the tornado that traveled 3 miles. Okay, so distance traveled is our first variable, or x. So that means x equals 3. That's what we're trying to estimate. And so as y'all might expect, we're going to take that number 3 and substitute it in here for x. All right, cool. That's what I want y'all to type into your calculator. 64.39 plus 41.86 times ln, the natural logarithm of 3. So type that into your calculator, pause the video, and then hopefully you get this for an answer. (110 miles per hour if you round). Go ahead and cut the video right there. Congratulations, y'all ready for your midterm exam. Good luck.